Get started here. Last talk's a lot of the day. I'll try to keep it moving along so everybody can stay awake, and I'll try not to run over so you can get out of here and get ready to get a beer. Or whatever your favorite frosty beverage is. So, the title of the talk's a little long. So I'm going to talk a little bit about the state of the cybersecurity and especially application security out on the internet. And you know, you're not paranoid, they really are out to get you. Or some of you probably are paranoid, but just because you're paranoid doesn't mean they're not out to get you. So, you know, maybe it's really more, instead of like the dog coming to attack your foxhole, it's probably more like the ninja chihuahua. He's going to sneak up in the night and attack you, and really, how scary is a ninja chihuahua? Well, script kitties aren't that scary either, but they can still make your application really a disaster. So, I'm Bob Wall. I used to work at Oracle here in town. I know a lot of you from there. I'm currently the CTO at a startup that's working on data security called Iron Core Labs. So I'll start out talking about some statistics and information about the state of application security on the web now. So these are numbers from 2014. Almost half of the people in the US half of the adults were hacked that year. I would expect that probably half of you in this room have gotten some sort of a breach notice probably at some point in the last couple of years. I've gotten, I think, 3. In that same year, 43% of US companies were hacked. So those are, you know, kind of alarming numbers. And in 2014, that's right, over 1 billion records were stolen in 2014. So you might look at that number and go, wow, that's big. Was it like 3 billion 10 years ago and we've battled it down and we're making it better and it got down to 1 billion? It turns out we're probably really going the other direction. This slide shows high severity vulnerabilities in web applications, and so a high severity vulnerability is one that, if it is exploited, is likely to cause a lot of damage, like lead to a data breach, for example. That were also considered low complexity, which meant it was not hard to exploit the vulnerability, and so the number actually went up 25% from 2010 to 2015. So we're actually going the other direction. We're apparently getting worse at application security. You know, in 2015, 35% more ransomware, 84% more bots, more spear phishing, more identities stolen. You know, everything was really getting worse. Either it was getting worse or we're getting better at measuring and reporting it. 32% of desktop and laptop computers, it was estimated in 2015, were infected with some sort of malware. And this is not, they're not counting annoyanceware here, they're talking actual malware. At the same time, only 0.03% of mobile devices that year were infected with malware. Maybe, if no surprise, they were almost all Android devices. So this is kind of more of a breakdown of that same number. As is not unexpected, Windows, the big winner in this category. A few things on Android, some, you know, VBA stuff in documents and stuff. But, you know, don't feel too superior if you do all your work on your phone. There were only 0.03% in 2015, but the number's going up fast. Malware is really on the rise in phones, so it'll catch up. Because more people are using them now, it's more of a desirable target, I suppose. If we switch to kind of looking at web applications, these are web applications that were tested mostly by professional pen testers. 86% of the applications tested in 2015 had serious issues with authentication, access control, or confidentiality. So that was up from 72% in 2014, so a big jump. And this is one of those numbers that you don't want to see that kind of jump in. You know, maybe your revenue, you'd love to see it, but not your pen testing failures. So this is kind of a wall of shame. of companies that have reported breaches. And as you watch it fill in, I imagine you'll see some of those companies that you might expect have some of your data. You know, this being a geek conference, Slack's on that list, so probably a lot of you have a Slack account. The IRS is on that list, so like it or not, they've got your data if you live in the US and work here. I know personally that the Office of Personnel Management had some of my data because that was one of the breach notifications that I got. So, you know, there are a lot of big names here that have been breached in the last couple of years. And we know more and more about this, right? The news coverage of breaches is going up pretty quickly. You know, when these hackers start breaching the place where you line up your illicit affairs online, that makes news and makes a lot of people uncomfortable. So maybe one of the reasons that the news coverage has started to go up is that more and more states have implemented breach disclosure laws. So these are laws that say if your company's data has been breached, you have to let people know. You can't just sweep it under the rug, maybe fix it, maybe not, and hope it doesn't happen again. These states all mandate that you disclose any breaches. And you know, disclosure, these breaches are only, these notifications are only required if they steal personally identifiable information that was not encrypted. So the people that are like taking your database and encrypting it with like 30-year-old encryption technology, and then it gets stolen and the hacker can go crack it in 3 hours, those wouldn't have to be reported. But for the ones that, for anything else, these states require that you notify your customers if their data is stolen. So, there are probably a lot of reasons why this is going on, but probably one of the big reasons is that access to data is being spread out more and more all the time. We need access to data from our laptops, our home computers if we're working from home, and a lot of people do anymore. We want to be able to get to that data from our mobile device. There are more and more partnership integration arrangements. There's, the Internet of Things, and we'll talk a little bit more about that later. All of these things are meaning that the data needs to be accessed from more and more places, and those places are not places that are, those devices aren't all plugged into your corporate network. So the plan that everybody used to have of building a big wall around their corporate network, maybe digging a moat, it just doesn't work anymore. In the past you would do that, and then maybe you'd drill a couple holes and put some conduit through it so you could run a VPN through there so that, if somebody did have to connect with their laptop, they could. Well, you don't want to have to fire up the VPN on your cell phone, and so the notion of perimeter security, as it was, really is no longer relevant, and I think that's probably a lot of the reason why the breaches are going up. If we look at how breaches happen, this is a pretty interesting statistic. The Department of Homeland Security estimated that really 90% of the defects were due to the problems in the application. So hackers are not out there cracking through your firewalls and your routers and sneaking into your network and then busting through Linux and, getting into the Oracle database, your MySQL database, and prying the data out of there. They're exploiting weaknesses in your applications and just going and plundering it that way. So it's a lot less work, obviously. If we look at what kind of vulnerabilities that we're talking about here, or the likelihood that a particular application will have some of these vulnerabilities, insufficient transport layer problems are, an application is 70% likely to have some problem in the transport layer that could be exploited. Over half of them are going to have some sort of information leakage problem. Cross-site scripting is on here, content spoofing, brute force attacks. When I first saw this slide, a disclaimer, actually, my partner, Patrick Walsh, put together almost all the slides, but he wasn't able to attend. So when he sent this stuff to me and I first looked at it, I was a little surprised to see that SQL injection is pretty far out there on the right end of it, but it's still out there. So if we look at the top 5 of these, insufficient transport, more often than not, that's going to be caused by not setting up SSL correctly, or maybe not setting it up at all. But even if you do set it up, if you set it up wrong, it's really not that hard to get through SSL if it's not set up correctly. Information leakage, a lot of times caused by people dumping exceptions or some sort of error logs, dumping them out to the screen so that the hacker who's trying to break into your system does something, they get an error message up and it says, it's got the version of the database you're using, maybe it's got the version of Apache, it's got the version of the operating system. So now they have all of this extra information about what vulnerabilities they might be able to exploit. A lot of these things, cross-site scripting, content spoofing, SQL injection, are almost always caused by poor input sanitization. You would think that by now we would all be aware of that, but I guess the statistics say that even if we are, we're not very familiar with what to do about it. Brute force attacks, people being able to just hammer your website and keep guessing passwords or whatever. That's caused by not having any kind of rate limiting a lot of times, and I can understand that. Putting rate limiting into a web application is not the easiest thing to do, but obviously if you don't, it's an avenue for somebody to exploit your application. So if we look at the first one of those, and if we look at a likely cause of poor transport, SSL is, a lot of times the problem, and 66% of the web is estimated to be using the OpenSSL package to provide SSL, and that isn't including even services that maybe they're using, like IMAP, that might be using OpenSSL under the hood. But a lot of you have probably heard in the last couple of years of like this raft of OpenSSL vulnerabilities, right? Logjam, Heartbleed, the go-to fail that Apple had, Drown this year. So OpenSSL vulnerabilities aren't getting weeded out. More and more of them are being discovered over time. And you can see that the severity is, the very severe ones, there's still plenty of them out there. Which is interesting because, one of the kind of the touchstone things that everyone's told when they're working on cryptography and stuff is, don't write your own. You're an idiot if you're going to go off and write your own crypto library. Use something that somebody else has written and that's been tested and vetted. And furthermore, open source packages are probably better because there have been a lot more eyes on them. Well, OpenSSL, the project was started in 1998, and it was forked from a project that started in 1995. So, 20 years plus into this thing, there have been a lot of eyes on the OpenSSL code. And they're still finding vulnerabilities. So, maybe that conventional wisdom is a little bit questionable. If you take a look at the OpenSSL code, you can maybe see why they're still finding so many vulnerabilities in it. It's really a mess. I mean, it's walking through the OpenSSL code is sort of like, driving by a car wreck. You can't help yourself. You kind of have to look over there, and then you wish immediately that you had not done that. The unit test coverage, my partner actually checked out the master branch from Git, ran all the tests, and measured the code coverage, and it didn't even make 50%. So, some of these things add up to it not being surprising that they're still finding severe vulnerabilities in this code. Other encryption pitfalls that you might have if you're using encryption for other than the transport layer, like another bit of conventional wisdom now is that you should encrypt your data at rest in your data centers too. And there are plenty of things still that can go wrong there. If you take all of your data and you put it into an Oracle or say a MySQL database and you encrypt the database, you can go home at night and say, man, I feel good, I did a good thing today. But there was this single key that you had to use to encrypt all that data. And furthermore, you probably had to put that key in a place where all of the applications that needed to fetch data out of that database could get it, right? Or else the database wouldn't be very useful. So if I'm a hacker and I want to get into your system and I want to steal all the personnel records out of your database, as soon as I can find a vulnerability in one of your applications and you know, a buffer overrun or something allows me to get in there and find that key, I've got your whole database. Having it encrypted at rest didn't help at all. Likewise, like I imagine those of you that have MacBooks maybe turn on the transparent disk encryption. I did. So if you're going through security in an airport, somebody steals your bag, takes your laptop and takes it home, and they pry the hard drive out of it, they're not going to just be able to go get the data off of it. But they won't do, you know, so thieves would do that. Hackers won't do that. And if they get into my laptop because, I've got some malware on it or something, the transparent disk encryption didn't help at all because it's decrypted and available while I'm logged into my laptop. If I encrypt all the data in my system, at rest, and I put the key somewhere, even if somebody can't get into one of my apps and steal the key that way, if they do manage to get into the network and the key's on the server somewhere, they're going to find it. You might as well not have encrypted it. So, there are just a lot of ways that encryption can go wrong if you're not careful. And a word of advice, because more and more companies now that are trying to sell services and software are cognizant of these problems, and they're going to tell you that their applications are encrypted, right? Our chat application is encrypted, this application is encrypted. And the most important question to ask after you hear that is, great, so who has the key? Do you have one master key that's sitting on your server somewhere? If so, that shouldn't be considered to be a very big selling point, because if you buy the best lock in the world and you put it on your drawer and you lock the drawer that's got your Ashley Madison account password in it, and you put the key on top of the desk, you didn't accomplish very much. So, to continue this trail of tears, I'll kind of switch to talking about, the kinds of vulnerabilities that we find out there and how prevalent they are. And this graph shows that, and these are actually measurements of companies that paid to have somebody do penetration testing on their websites. These aren't just random companies. So these are companies that actually probably are concerned about security and may have tried to do some things to make the numbers better, but you can see that in the bottom one, like the public administration sector, that only 15% of the companies in that sector that had applications tested had applications that had a serious vulnerability less than 151 days a year. And 64% of them, they had some application out there on the web that had a vulnerability every day of the year that it was tested. So, those aren't great numbers. And if we look at then, when we find out that there are vulnerabilities, these guys, some pen testing company found these things, they notify the company. The average number of days to fix is really long. Like if you look at the bad end of this scale, in retail, an average of 227 days to fix a vulnerability. That's the average. That means that the really hard ones that are hard to fix, they're going out there, they're staying out there for a year plus, right? So, the combination of those things is not good. And so it's like, okay, things are bad, you've got these vulnerabilities out there. Do I really need to care that much? So if we look at what it costs when somebody does exploit one of these vulnerabilities and say you have a data breach, there are some significant hard costs that you can incur. The estimate, and these are 2014 estimates, is that the cost per breach record was around $200. So when you think back to 1 billion records stolen in 2014 and $200 each, that's a pretty big number. And that number increased in 2014 by about 9%. So that added up to about $3.8 million per breach in hard costs to the companies, and an estimate of $400 billion in cost to the global economy in that year. So that's why you should care. Those are pretty big numbers. And so, okay, maybe, are there things that I can do to mitigate that while I'm trying to get things fixed? You could buy cyber insurance. The good news, they probably do better than a lot of healthcare plans, and they paid out 83% of the claims in 2015. But if you look at the dollar amounts that they're paying out, they don't match very well with the dollar amounts about what was being stolen. So they're paying out small percentages of the cost. And so that, you know, maybe you want to have cyber insurance, but it's not gonna be your golden shield that's going to protect you from all data breach problems. And in addition, there are soft breach costs that, you know, by the name you can guess that they're not as easy to put a dollar figure on. But if we look at Living Social, was a company, social company that they started out as kind of a competitor to Groupon, and they were trying to pivot and find a marketplace. And in 2013, they were hacked. 50 million customer records were stolen, and subsequently their revenue dropped to 15% to 20% of what it had been before the breach, and they ended up with 82% fewer employees at the end of that process. And their executive team identified the breach as the most significant cause of those declines. So. You know, damage to your reputation is hard to put a dollar amount on, but it's also very hard to fix. So, you know, companies are hearing more and more about this. They're trying to do things about it. So they're spending more on security, definitely. But oddly enough, if you think back, I had a slide a while ago that said that 90% of the problems were actually in the application and only 10% of the problems were in the network. Oddly, almost 75% of the spending on security is going into network security, and only a little more than a quarter of it's going into app security. So that seems a little bit backward. You know, if we look, they estimated 31% of all the security breaches that happened in banks in 2015 were attacks through web applications. And this number held out across other industries too. Financial services, almost a third of them were web app attacks. IT services, over a third were web apps. So, you know, the application security was definitely a significant contributor to all of these numbers. The information technology one lists that cyber espionage is an even bigger factor for IT companies. And so this is spy versus computer. This is North Korea getting really angry at Sony for releasing a movie and pounding their way into their systems and stealing a bunch of stuff and releasing it on the internet. And you know, one of the ways that they do that by phishing, 2/3 of the cyber espionage attacks that succeeded were phishing attacks. 27% of the victims that were attacked were manufacturing corporations, and public sector were another 20%. And but fortunately enough, when we looked at the billion records stolen, only 0.8% of those were actually, of the total, were actually due to cyber espionage. But you know, when we talk about these things, and like we talk about how they get in and phishing attacks, it's still true in 2015 that 23% of people who got phishing emails opened them. Hopefully for a lot of us in this room, that's a surprising number because, you know, we should know better. But, you know, almost a quarter of people still open those emails, which is why you still keep getting them every day. And 11% of the people that got them actually opened the attachment on them and got speared. So, you know, hopefully this is I'm trying to paint a picture of things that are pretty scary, and you know, it's pretty scary and it's getting worse. And one of the reasons is because the Internet of Crap. I'd call it the Internet of Things, but I think really the Internet of Crap is probably a more fitting moniker for it. They've estimated that 70% of the devices that are considered on the Internet of Things are vulnerable to attack. 90% of those devices are collecting some sort of personal information. And on average, each of those devices has 25 different vulnerabilities. So there are a lot of places for that device to give up your personal information to hackers. And you know, the number of devices on the Internet of Crap is estimated to get over 50 billion devices by 2020. By 2020, they're estimating that 1/5 of all the cars will be networked. And so you can guess that your car's probably going to have a fair amount of personal information that you would rather hackers didn't have. So the state of security on Internet of Things devices is way more abysmal than the state of security on everything else. So this is a significant concern. If we kind of switch from that to looking at healthcare companies specifically, in 2015 there were 277 healthcare breaches, 112 million records stolen. They estimate that these records are worth $10 a piece on the black market. So you can see why people are motivated to steal them. They're worth a lot of money. 67% of the records that were stolen across industries were accounted for by these healthcare breaches. And so, even here in Montana, we're not immune. These are numbers from the first 3 months of 2016. Deaconess Hospital had a small security breach, and New West Health had a more significant breach already this year. So, hospitals and the healthcare industry itself is under active attack. Once a breach has happened, it typically takes 229 days before the company that was breached figures this out, on average, or the median anyway. And then on average, once they find it out, it takes a month for them to even respond to it. And I found this interesting, that 67% of the companies that were breached actually found out about it because somebody outside the company told them about it. And I suspect that a lot of that is somebody calls up and says, hey, we just thought that all of your records are on sale out somewhere out on the dark web. And so to kind of sum up, breaches are going through the roof. Firewalls and traditional network security models are not sufficient to protect data. Apps are the problem by a large margin. A lot of the vulnerabilities that we find in applications are really not very hard for hackers to exploit. So you don't need to be the hardcore ninja to break into your apps. You can be one of the Scripty chihuahua ninjas and get into the apps. The Internet of Things is just going to make things worse exponentially. And this bad security is really costly, and it could cripple or potentially kill your company. So software developers really need to step up their game. And we ought to be able to do that. We make our living solving problems, right? So if we look at people that are being trained to enter the industry, specifically if we look at bachelor's degrees that are being granted, there was this dip for a while. People stopped getting bachelor's degrees in computer science, but it's on the rise again. And in 2014, 56,000 people got bachelor's degrees in computer science. So you would kind of expect, hey, help is on the way, because we know about application security, we know about security now, so we're probably doing a lot better job training people that are coming out of school now to deal with this stuff. Turns out that's probably not true, unfortunately. Of the top 20 computer science schools, the top 20 undergraduate programs in computer science, the number of them that required a secure coding class was 0. Not a single one of the top 20 required a secure coding class. Several of them, maybe all of them, probably had optional classes in secure coding or security, but none of them required that. So we might be on our own for a little while longer to work on this problem. So for the rest of the time, I want to talk a little bit about things that we can do. These are not super in-depth suggestions or anything, but some ideas about what you can do in the process of developing your applications to try to mitigate some of these problems and do a better job at application security. And so we'll look at some phases of the software development lifecycle, and you'll notice this first one is not typically a bubble that you see on a life cycle diagram, the employee acquisition and training, but if you're talking about application security, it's a pretty important one. So we start there, go through requirements and design, development and testing, and then we'll talk a little bit about what to do once things are out in production. So first off, training. You need to teach all of your developers about secure coding. I think, when I was talking about the most common web app vulnerabilities, a bunch of them were still based around the fact that applications were not doing very good input sanitization. So everybody who's writing any code that's going to ship for your product needs to know that you can't just take the crap that people go and type into the boxes in your web application and stick it in a SQL statement or build some JavaScript that pops that back out to a browser. Everybody that's going to be writing software needs to know some basics about doing secure coding. It would be a great idea to teach all of your QA people about ways that they can do basic security testing once the developers get done. There are a lot of different things that can be done there, but I think a lot of QA people aren't really trained in those techniques. And so you need to teach all your new employees that, and you probably need to give refresher courses every 2 years because, as a developer, I know I'm lazy, and I know a lot of other developers will admit to me that they're lazy too. And so if you don't kind of keep this fresh in people's minds, it's a lot of these security things are not things that, you don't look at the application once it's done and go, yeah, this application's so awesome because the people who wrote it, they were really careful about sanitizing their input. The product manager's not going to put that on your spec sheet for why your application is going to be the next greatest one in the world. So you just need to make sure that people have it in their mind that it's important. Then as so all your employees, your QA people are trained to test for security, your application developers are trained on how to write secure code. When you start designing your application, your product manager needs to make sure that security is an important part of the requirements for the process too. Make sure, if you're putting together lists of personas that will interact with the system, put malicious users on there. They're out there, they should be included in the personas. When you're working up the requirements, make sure you require things like account lockouts if people fail their password too many times, or rate limiting for form submission so people can't brute force attack your system. Those have to just be built into the requirements. Just an interesting aside about why you need to do some of these things. The average web user now is estimated to have 25 different accounts. I don't know, this is probably a couple of years old, it's probably higher than that now. And the average number of passwords that those users have is 6.5. And I certainly, until I finally started using LastPass, I probably had 1 password or maybe 2. So that wouldn't matter, except that it's easier all the time to, if somebody's database is weak and they cough up your encrypted password, it's easier all the time to take that thing and run it through something and crack it and get your password out of it and then go and plunder your data in other systems on the web. So, if you design the system and you've got security as a focus of your design, then when you move into implementation, you need to write secure code, right? And there are a lot of places out there, there are a lot of really good checklists for secure coding techniques and checklists to go through to make sure that you follow them. The Open Web Application Security Project, OWASP, has a really good set of cheat sheets that you can download. They're free. And there are a number of others out there that have cheat sheets or checklists that you can check off to see how well you're doing on secure coding and application security. Like I said, you need to make sure you're designed to talk about how you're going to do input sanitization. Think about how you're going to do rate limiting, and design those in. And you should also specify not just the software, but start thinking about the operational expectations, the way that you're going to configure your production environment too. I know from experience, and other people that were right nowers here can back this up, that it's not all that uncommon for the developers to go in and develop this thing, and just like, well, sure, it runs on our development servers, and then somebody over there in operations is going to wave their magic operations wand, and they're going to install this thing, and it's just going to run great. And I don't need to talk to them. I don't need to know how they're going to do that. They don't need to know how I did what I did. Somehow it'll all just work together. And that turns out to not be the case, and especially when you're talking about how to make everything secure. So you need to pay attention to that during the design. Then when you move into implementation, you know, there's definitely some things that you will want to be doing. You know, a lot of people now, I'm sure, are using some sort of Agile or Scrum process. You know, you come up with this big backlog, and then developers go pick items off the backlog and start working on them. So, you know, a developer goes and picks off one of these work items, starts working on that. They should be, you know, if they've had some good security training, hopefully they're writing less bugs into the code, less security bugs into the code, you hope. And then, you know, a lot of them, several people have mentioned that they should be doing unit tests after they get through writing their code. It's a great idea when you're writing unit tests to not just cover all the cases that you can envision, all of the happy path cases, and some of the sad path cases. Use a testing framework that lets you do randomized testing too, because, you know, developers, it turns out, aren't all that imaginative when they're trying to dream up all the sad path cases. And a lot of times, the random number generator, sometimes it's great at coming up with sad path cases. So build randomized testing in there too, as part of your unit tests and your functional testing. You know, when you get to the point where it's passing all the tests and you're going to pass it off to continuous integration, include static code analysis in your continuous integration. You know, there are tools out there like Fortify and other static code analysis tools that are fairly good about picking up on some potential problems in your code that could be security vulnerabilities. I know that a lot of developers are not happy when you start talking about doing static code analysis, because a lot of static code analysis tools, the first time you run them, they smack you in the face with you know, tons of false positives. And you know, nothing sucks worse than going through 20 pages of false positives trying to find out if there's anything that you really need to worry about. But if you'll take the time, most of the tools will allow you to kind of tune their detection so that you can identify the cases in your code that are really not problems, and you can get that false positive list shrunk way down. It's definitely worth it to take the time to do that. And some tools are easier than others. Fortify is not easy to tune that way, but other tools are pretty good. So, you know, take advantage of that and use static code analysis. It will increase, it will catch bugs. So then, you know, it makes it out of CI, and all your tests are passing, your integration tests, your unit tests. It goes into QA, and you know, maybe you have a manual QA process. Your QA team, you know, they need to be testing to make sure the application does what it's supposed to be doing, but some of them should be trying to hack the application too. You know, they should know ways that are common for breaking in, and they should be making sure that those don't work against your system. And that's part of when I talked about QA getting training, making sure that they know what the techniques are that they should be applying in manual or scripted tests against the system. Once you get done with that and you're ready to release, it can be very beneficial to pay for an audit of your system, your application. You know, if you're releasing on a daily basis, you know, there were some talks about continuous release earlier. You know, you're obviously not going to do that on every release, but periodically having someone go out and do some testing, even automated pen testing. You know, some of those slides about the numbers of problems in web apps that are detected, a lot of those were done with, you know, white hat security or somebody running an automated pen test against their applications. So, you know, it might cost a little money, but it will cost you less money than it will cost you if your system does get breached and somebody steals a bunch of data from you. So seriously consider hiring somebody to do that. So, you know, you need to kind of put security into every step of the development process. And, you know, you get to the end, if you're a developer, you're in development, you're in QA, you got to the end, it's made it through all of these things, you hit release, well, you're still not done. You need to plan for what's going to happen while the application is out there in production. And there's a set of, kind of a set of things that you can do once the application is in production, or when you're getting it ready, when you're setting up the production environment. First of all, harden the systems that are going to run the application as much as you can. Use the principle of least permissions. Don't give things the ability to do anything more than what they need. Separate concerns out. This thing should do one part of the process, this thing should do another. And segment, uninstall anything that you don't need on the systems. That's just a smaller attack surface if you do that. Encrypt. I know I said some disparaging things earlier about, doing like encryption at rest and stuff. Do it anyway. You need to do it right. You need to be careful about it, but just do it. You obviously should be using HTTPS. Do some database encryption on disk. If you've got sensitive data that's being processed, do extra encryption on that. Make it harder once somebody gets in to make off with usable data out of your system. Use SSH. Don't have a password stored in a file somewhere that every app can open up to figure out how to decrypt things. Two-factor authentication is a great idea. People building apps now would be idiots to write everything from scratch, probably, right? Unless you're in a really specialized vertical, you're going to be using a lot of third-party libraries. And again, I can say this from experience. Keeping those third-party libraries up to date is a painful process, but you have to do it. I can also say that from experience. I guess it depends on what the library is, but there are a lot of libraries that are coming out that don't have some sort of security updates, some of them very frequently. So you need to make sure that you're putting those into the system. And you can't do that unless you've got good regression test suites. And I can say with confidence that that's a lot of the reason that places I've worked in the past didn't keep up on updates, because it was just too painful. So you need to make sure that it isn't painful so that you can do it. Same thing with server updates. You need to make sure you've got all the latest security patches for Apache or Linux or whatever you're using. Make sure that you're monitoring things once they go into production. Log a lot of stuff, monitor it, alert on it, and make sure that you put automation in here too, because if you're going to expect that somebody's going to sit and watch a screen and see an alert come by and they're going to go, oh, that's bad, I need to do something right away to shut this down. We're being attacked, you're doomed. So you need automation to make sure that you catch the important things, the important events that you get out of your monitoring and logging. Do a little threat intelligence, try to keep up on what new vectors of attack that people are discovering. Do audits of the production environment after you're done with development. It can't hurt to periodically, fire up a port scanner and make sure that the last time somebody installed an operating system update, some process that you're not using didn't get started up automatically. Try to keep things running clean and understand what you're running. And have a process for how you're going to respond if you do find problems. If you find an event that you need to respond to, know what your process is going to be to get emergency releases installed, or when you're going to update software. Make sure that these events don't get lost in the shuffle. So, this is kind of the circle of geek life here. It's going to go on forever, and you just need to get used to it. Have a set of processes in place so it's easy to do. So I think that's pretty much it. Again, I'm with Iron Core Labs. My partner Patrick Walsh and I are the only two in Iron Core Labs right now, but we're working on encryption solutions that will make it easier for developers to put end-to-end encryption into applications and to do things like key management a lot more easily, so it will be a lot easier for you to build secure applications. We'd always be happy to talk to anybody who has any questions about whether we could help them with application security. So Any questions?